oxidation and reduction. Okay, so for oxidation and reduction, we call it as redox reaction. Redox reaction is the chemical reaction where oxidation and reduction take place simultaneously. Okay, so we'll look some of the characteristic of oxidation and reduction. So first of all, we go through one by one, okay? So for oxidation, the redox, it came from this one is red from reduction and ox from oxidation. So we can know that redox reaction is where the oxidation and reduction occur simultaneously. So for oxidation, nama dia kan oxidation. So it's something related with oxygen. So in terms of oxygen, dia akan gain. Dia akan tambah oxygen atom. Not oxygen gas, okay? It's just like oxygen atom. And then for reduction, it's like reduce. So in terms of oxygen, dia akan lose. Loss of oxygen atom. Okay. And then in terms of hydrogen, hydrogen ni lain sikit. In terms of hydrogen, if oxidation, we will lose the hydrogen. And then for reduction, dia akan tambah hydrogen. Okay. And then for electron, if you look at the cells and like voltaic cell, chemical cell, and if the question asks you to write the half equation for oxidation and reduction, you can know that oxidation is always donate electron or release electron. So for in terms of electron, dia akan donate, jadi lose electron. And then reduction is always gain electron. So dia akan plus. And then in terms of oxidation number, this one is very easy. It's just almost the same as the tambah oxygen, reduce oxygen. So oxidation number, dia akan increase, this one akan decrease. This one is very similar. Okay? The oxidation number is like Fe2 plus, Fe3 plus. This one we call as oxidation number. This one. Okay? Okay, so this one is summary. So later I will susun nicely, then I will send back in the group. So this one is just short briefing. So, okay, this one we settled already. And then let's move on to equation. Okay, if they give you the question like this, our SPM 2023 paper 1 was very easy. There's a lot of redox question where they give the equation and they ask us to not predict state, which one undergo oxidation, which one undergo reduction, which was very, very easy. So this one I will just go through. This one was like SPM this year format, my batch. Okay, so they give like this, and then they ask which substance undergo oxidation, which substance undergo reduction. So how to know this one? This one is easiest one, the magnesium plus oxygen become magnesium oxide. Okay, so first of all we tengok magnesium. How to know whether magnesium underwent oxygen or reduction? We will see the product. This one, magnesium. There's only one product, okay? Don't need to be confused. It's okay. One product also, it's okay. So for magnesium, this one is reactant part, right? Okay, we cari magnesium in the product part here, right? Tapi kan ada stick one oxygen there. Okay, tadi we learn already kan, if tambah oxygen atom, is it oxidation or reduction? This one, right? It's oxidation, right? If tambah oxygen atom. So here at first only magnesium. Tiba-tiba ada oxygen atom kan? So the substance that undergo oxidation is magnesium atom. magnesium atom. Okay, so which one undergo reduction? Definitely is oxygen gas, right? So if you identify one already, the other one is very easy. But just to double check, if you want to double check, this one oxygen, mula-mula dia 2 oxygen. Tapi in the product part, there's only one. One hilang already. They are balanced. This one, the equation is not balanced yet, but this one is just to determine the oxidation and reduction. In exam, don't write like this, okay? Belum gonna balance. So this one, oxygen 2 kan, tapi here only one. So reduce kan the oxygen atom. So this one, reduction is oxygen gas. Easy, right? Okay. Let's look at the example for hydrogen. This one, belum balance, okay? This one, S, and then, wah, this one banyak kok. Banyak produk, banyak ting kan. Nampak susah kan? It's okay. Ada method. Okay, so for this one, so first one, let's try this method. This one we kasih connect supaya it's easy to see. This one red color, this one purple. Okay, tadi we learn already kan? Okay, let's try to compare. This one got 2 hydrogen, this one only got 1 sulfur. Okay, the hydrogen hilang already kan? So if losses of hydrogen is oxidation, right? As we can see here. So we can say that this substance undergo oxidation. Easy, right? Until here. Okay. And then the other one, oh, very obvious. If one oxidation, one mesti reduction. If this is redox. But some equation, not everything is redox equation, okay? Only some. So you need to identify well. So this one, the another one, chlorine gas. And then tiba-tiba jadi hydrogen chloride. Tambah oxygen kan? Okay, if tambah oxygen, not oxygen, tambah hydrogen, it's reduction, right? Tambah hydrogen. So we can call this chlorine gas undergoes reduction. It's very easy to identify kan? Our SPM, they ask this kind of questions. Like not only one question, there's 2 questions like this thing. It was very easy. Okay. And this is very simple. And then let's see. I think this is more than enough already for the example of oxygen atom and hydrogen. And let us look at the electron part. The electron, you guys know half equation, right? Okay, let's try to write half equation for which one of them? For magnesium. Kasi senang sikit lah kan. So for magnesium, dia akan donate. Dia akan magnesium ion kan. Ni cation ion kan. Cation ion tekan accept electron. Dia akan bagi. Jadi this one, magnesium, dia akan donate electron. Jadi magnesium ion plus 2 electron. This one is giving, okay? Giving the electron. So this one will fall under oxidation. So we can say magnesium undergo oxidation. This one we can identify from the equation. This one. Okay, we kasih pandai-pandai. We balance dulu. This one, 2. Okay, balance already. So if they only give this information, how to know whether which one undergo oxidation, which one undergo reduction, using in terms of electron, tadi we use in terms of oxygen, right? Oxygen atom, but now we try to use electron. So, as you can see, mula-mula dia atom jadi ion, kan? So, this is the half equation for magnesium. So, for oxygen kan, okay, we already know that this undergo oxidation. So, oxygen gas mesti undergo reduction. So, this one tambah 2 electron Jadi O2. Okay, this is the half equation. Dia akan accept. Okay, so how do we actually write the chemical equation? This one is chemical equation. This is half equation, half equation. If we combine this, then we can write this. Okay, how? When the question asks you to write chemical equation, we don't include. Only when you go to very high level, maybe you can see some. But for our SPM level, very jarang. So we need to neglect the electron when you write chemical equation. So this is how you write magnesium. You take the product from the reactant and product. This one you take, this one you take. You don't take this, you don't take this. And then if this one combine, jadi magnesium oxide, right? So this is where the chemical equation came from. This one exactly the same, right? Okay. This is the reason behind of it. Okay, this one was a bit extra. And then this was in terms of electron. So this one in terms of oxygen, this one in terms of hydrogen, this one in terms of electron. The oxidation number, this one is very easy. But first of all, we need to know how to calculate the oxidation number. Okay, how do you calculate? First of all, we need to know that for atom, the oxidation number is 0. For let's say magnesium. Why 0? Because there's nothing here. And then gas also. Chlorine gas also 0. Why? Because there isn't anything here. Okay, tapi if potassium ion got 1, right? But we don't write as 1 plus kan. We write as plus only kan. So this one, we can say the oxidation number is 1. This one is 0, this one is 0, this is 1. Chromium. Chromium, no, we use a bit easier one. Zinc. 2 plus. The oxidation number is 2, 1. So, for simple thing is very easy. But let's move on to iron. Apa mau Yusa? Okay, carbonate ion. Carbonate ion, the oxidation number for iron, okay, we don't kasih separate. This one is carbonate ion. So we need to look at the whole thing. So this one is -2, and so the oxidation number is -2. And then, okay, how to calculate? Ada one question yang they bagi one ion. I forgot which ion, but they ask you to calculate the oxidation number for carbon here. Okay, so how to calculate? This one we use as the simple notation for oxidation number, the bracket. And then plus, the oxygen has 3, right? And then the oxidation number for oxygen is normally -2, right? Like oxide ion. You remember, right? Okay. And then equal to -2. And then if you calculate, you will get +4. So this is how you calculate. It's like basically very simple maths algebra. So other my friends actually sesat here, but you just need to identify this one. This one is the key point. This one is the very important. It's like in maths, you need to build equation. Mesti ada something equal to 0 equal to 2. Yeah, this one is the key point for this one. And then this one is like expression. Okay, so this one is like you put this as x plus 3 -2 equal to -2. This one is basically the same as maths. So this is how you calculate. Quite easy, right? And then we look at another ion. Okay, this one. Oh, yang nampak susah kan? And then the question asks, what's the oxidation number of manganese? Okay, so how to calculate? So we anggap this is x. This one also very important, okay? This one, okay. Actually, you can write it x if you rasa like confused. But I prefer to write like this, supaya I can see what I doing right now. Okay, plus 4. There's 4 oxygen. So for oxygen, the oxidation number for oxygen is -2, right? Equal to, okay, this one is important, I say. So this one you drag here. Tapi don't put like this lah, okay? It's -2. So you put as -2. And then if you calculate, you will get -8, then +6. And in chemistry, SPM chemistry, the marking scheme is very strict. If you just write 6, sorry, you won't get mark. Because the examiner don't know the 6 referring to -6 or +6. They don't care the magnitude. I mean, they also care, but they really, really emphasize the part where magnitude plus the sign. Same goes to calculation of the voltage. Let's say like you got 1.1 voltage. Cannot write this 1.10 voltage. This one cannot terima. If the pemeriksa very strict, they won't give you mark. Mesti ada plus or minus. Because chemistry, the voltage, the sign varies very, very important. Okay? This one bear in your mind, okay? My friend banyak kena tolak marka because of this. And then I also ever kena. Okay? So this one, the sign very important. This one also. Tadi also. This one. Tadi +4 kan? Yeah. Okay, this one is calculation of oxidation number. It's very easy, right? So far, any question? So far, so good. Okay, no question. Okay. Okay, everyone good. Doing great. Okay, and then now we try to look on a bit complicated one. It's not complicated, but this is kind of surprise for me because I thought oxidation number for oxygen, I thought is always -2, but sometimes no. For hydrogen peroxide, it's a bit different. Okay, if they ask you to calculate the oxidation number of oxygen, bukan oxidation number of oxygen is -2? No, that's wrong. For hydrogen peroxide, it's a bit special. This one. Bear in your mind, okay? We know that hydrogen is +1, kan? Okay, so we try to calculate. So we try to build up the equation dulu, supaya senang. Okay, I said before, if there's nothing on top here, corner, the total oxidation number is 0, kan? Okay, so we try to build the equation first. Plus 2O equal to 0. But the question asks you to find this one, kan? What's the oxidation number of oxygen in the hydrogen peroxide? So we already know that hydrogen is +1, kan? Okay, we try to calculate. Let's see what we get. Equal to 0. And then, if you try to calculate, equal to -2. So if I simplify, the oxidation number of oxygen is -1. Yes, it is possible, but only for hydrogen peroxide. Yeah, we only thought the oxidation number of oxygen is -2, right? But this time it can be -1. But this is very special case for hydrogen peroxide only. Okay, this one is just to bear in mind. Because my teacher ever asked me, and then I was quite surprised when I calculate this because I didn't know about this. Okay, and then okay, now let us move to for oxidation. If any substance undergo oxidation, the substance itself act as reducing agent. This one is just kasih terbalik. This one, yeah, when I first time masuk Form 5, I also took a bit of time to think, okay, this one undergo oxidation. Then which one act as oxidation agent? Sebab, no need to confuse. If The substance sendiri undergo oxidation, it cannot act as oxidation agent. Agent is something like you help something to occur. You sendiri cannot help. So you, when yourself undergo oxidation, they akan act as reducing agent. Agent is something like you kas tolong. Okay? And then this one, if something undergo reduction itself, they akan act as oxidizing agent. This one is very, very important until your SPM. Okay, ada paper one, banyak in paper one question. Okay, this substance undergo reducing agent. This substance act as reducing agent. Which of the following is true? They ask like A, B, C. So you need to know the basic concept. Some of the students, they cannot answer because, I don't know, maybe they forgot reducing agent undergo oxidation. They thought reducing agent undergo reduction. Actually, no. Okay? This one yang all the first Form 5 student bingung. So this one mesti bear in your mind. Reducing agent undergo oxidation. Okay, I put it that side. Okay, reducing agent undergo oxidation, oxidizing agent undergo reduction. This one is the most important thing I can say in this chapter, the first subtopic. This one is very important. Paper 1, paper 2, everything important. Okay? Okay, so now move on to electron transfer. I think this one I already explained here, this one. But I combined with the one yang how this one can be construct. Came from this and this, right? This one. So I think this part we can skip. And then if you see the textbook, right, they give you the example of oxidizing agent, reducing agent. That one, if you feel like you cannot faham, for me, actually I memorize. Because some of the exam paper one, they really like to ask, or paper two also got, they ask you to write some of the oxidizing agent and reducing agent. So for me, until SPM, I actually memorized like the long equation. So for oxidizing agent, we try to go through. Okay, so for oxidizing agent, as I said, undergo oxidation or reduction? Reduction kan, sebab terbalik. Okay, so oxidizing agent yang paling famous, yang they really like to ask, they really want us to know is the first one, acidified. Actually, why must be acidified? Actually, I question myself a lot when I first time learned this. Why not just potassium manganate 7? Why must he need acidified? Actually, the acidified is to produce water. The acid, dia akan react, lepas tu dia akan produce water at the end of the product. Okay, so this one, how you write? KMNO4. This one, the half equation is quite long. For me, actually I memorize until my SPM. So this one, tadi we calculate kan, the iron. For SPM, you don't need to write aqueous solution or solid or liquid. You don't need to write physical state. You won't get penalized. So if you think it's very hard for you, very tough for you, better don't write. If you're wrong, you won't get marked. So better don't write the physical state, okay? Yeah, the textbook stated you don't need to follow 100% for the physical state. No need to write. Just don't write. It's very bahaya. And then plus 4 hydrogen ion plus 5 electron. Okay, I already told you before that oxidizing agent sendiri undergo reduction. That's why you can see the plus electron sign. plus electron is reduction. You see? Here. Okay? So this one is tambah electron. Tambah electron, dia akan produce Mn2 plus 4 water. The water came from the acidified here. Acidified is refers to hydrogen ion actually. Yeah. Sebab acid kan. Acid is what? We form 4 we got learn, right? Acid is something chemical substance that ionize in water to produce hydrogen ion, right? So the acidified mesti acidified sebab dia akan bagi hydrogen ion to produce water. Okay? So this one, okay, from now on I will teach you in terms of increasing of oxidation number. The last one I haven't touched, right? Okay, oxidation number. For oxidation, it's very obvious dia akan naik. For reduction, dia akan turun. Okay? So, okay. For Mn, manganese, we try to calculate. Tadi we already calculate kan. Dia akan jadi positive 6. So, mula-mula kan, it was positive 6. Tapi kan, this one is the reactant, okay? Tapi, the product, you see this one, Mn, is positive 2. Positive 6 is greater than positive 2. Maksud, the oxidation number actually reduced, right? So when the oxidation number reduce, sini is reduction, right? So we can prove that this one undergo reduction. So this whole thing is reduction. So this is very clear, right? This is the reason behind of it. Okay, and then let's look at another example for oxidizing agent. The same thing, acidified potassium dichromate. Acidified here also important sebab bagi hydrogen ion. Potassium. This one in your textbook, okay, don't worry. Then dichromate. 6. Okay, one more. In SPM, sebab ikut IU pack, I heard that they kasih strict. So here, when you got space like iron, okay, if they ask you to write iron 2 sulfate, if you write jauh-jauh like this, you won't get any mark. Yes, you got any question? Okay, so for here, if you write space, sorry, you won't get any mark. They will cut mark if the marks are very strict. I hope that they will make it more stricter. So, iron mesti kasi stick. Sebab IU pack also actually got say mesti stick. Sulfate. Like this. So this one is the very, very small thing that actually can cause you to lose mark. So just bear in your mind, okay? Okay, kasi stick, and then dichromate. 6, how to write? K2, chromium 2, oxygen 7. Okay? So this one also, the equation is very long. So for me, I just memorize. But fortunately, SPM, they didn't ask like this gila-gila punya. Actually, chemistry SPM was quite easy until section C. It's not hard, but it's just, it's very unexpected. Okay, this one. Okay, this one. As you can see, ada water sebab ada hydrogen. Ion. Okay, this one also the same thing. We try calculate. You guys know how to calculate, right? Okay. Chromium 2 plus 7. You akan dapat this kan. And then if you try to calculate, tekan calculator. Okay, you akan dapat, okay, this one. 1, 2, kan, lepas tu akan dapat 12, positive 6 kan. Positive 6, jadi positive 3. So this one also we prove that this is reduction. Okay? Okay, and then yang lain also the same thing. So this one is in terms of increasing or decreasing of the oxidation number. So we already completed all 4, and then I already show you the example. So until here, so this one where like maybe you school reopen, then maybe you guys learn this in like 2 to 3 days or maybe 1 week. This one is the really the summary. Okay, but you really need to try some question just to double check whether you fully understand or not. Because yeah, you see right now and then you take notes, take my notes. Maybe you feel like, oh, okay, I understood already. But the real part is that you really need to train yourself using your own brain how to apply to the questions. That's how you can get A plus. Okay. So until here, any question? So far, so good. Good. Okay. Yeah, this part is actually very easy. Okay, quite easy compared to the upcoming. So okay, we completed all 4. Okay, and then let's move on. And then they suka tanya the color. Okay, now we go to a bit of drawing. Okay, this one. Okay, sorry for bad drawing. Okay, I will just use my freehand. This one, some client they got asked us to draw for trial 2022, not 23. This one, okay. This one is YouTube, not the YouTube that you guys like to watch. Wait, it's ugly. Okay, and then ada like this. Oh my god, it's ugly. Okay. And then this one, in the marking scheme, they call it as functional diagram. Okay, what's functional diagram? Actually, how do they mark our drawing? Our drawing no need to be like Picasso or anything. Like no need to be like PSV student. No, we are STEM student. It just need to be functional. Okay, apa maksud functional? Okay, when you draw this, okay, when you draw tube, the tube mesti less than half. Because kan, imagine ada test tube like this. Then you kasih masuk the stopper until inside. Then how you gonna take it out? So this one we call it as not logic. So you cannot take it out. You cannot conduct experiment. So we call it as not functional diagram. So this one mesti think of this also. Okay, draw like this. Mesti more than half this thingy. So I prefer to draw one stick like this and then I draw half here like this. So it's much more easier. Okay, and then we draw the carbon electrode. This one must know how to draw. And then draw the stopper, decorate sikit. Okay, and then kasih like this. Okay. Okay, exam draw cantik-cantik, okay? And then this one also very important. Ada got 2 solution kan? The 2 solution you cannot put like this. That one also not functional already. Okay? So this one mesti cannot touch. Okay? I think some of you already pay attention in class, know why this work like this. Sebab this one, the below here, we need to put what? Dilute sulfuric acid, right? And then this one got another 2 solution. And then if let's say this carbon electrode, 2 carbon electrode kena the dilute sulfuric acid, right? Sometimes it can react like the reaction kena kacau. Jadi this one, imagine you pull up here until here. Kena mix lah here kan, in the at the boundary kan. So this one mesti grow like this, okay? Jangan dekat-dekat. Nanti kena tolak markah. Okay? And then here, Question. I want to ask what's the function of dilute sulfuric acid? Anyone knows? Anyone knows? Ya, betul. Ya, betul. To allow the movement of freely moving ion. So sebab the electron dia akan pindah pergi sini sana kan. Jadi this one is like the road lah. Dia allow to move. Sebab let's say lah ada ni kan. Ada Romeo sama Juliet. Tapi they want to meet each other tapi cannot kan. Mesti ada bridge kan. Let's say here like the ocean lah. Pacific Ocean lah let's say. Like they cannot cross over. So the dilute sulfuric acid dia act macam bridge lah. Supaya they can cross each other and then can meet each other. Macam gitu. Okay. Okay, this one and then okay, galvanometer how to draw. Just draw one circle and then you put G. That's it. And then kasi connect dah. Di tengah better. Like this. And then you put two different solutions. Actually, here you can put whatever you want. Like here oxidizing agent can, here reducing agent can, here reducing agent can, oxidizing agent can. This one is up to you. And then the color I will touch later. The part where we learn the chemical cell, I will touch together with the color, okay? For this one. So this one is, I just want to tell you that this one must know how to draw, okay? Very simple actually. Nampak? Bida pun is okay. Asal kan, here, this part, functional. And then this part. And then always remember the solution in chemistry mesti okay? Jangan kasih shade macam ni. Okay, jangan kasih ni. Not functional diagram, okay? Okay, let's move on to okay, yang tadi yang calculation tu already kan. And then we move on to cells where most of the student confused. Okay. This one, actually for me, during my time, I didn't really confuse because I made myself these notes. Okay, I will share with you guys. So for simple cell, which we call as Voltaic cell, this one I got covered before during my last time class. Voltaic cell, the first thing that you learn in the Voltaic cell, we have two types. One is simple cell. Yeah, literally simple. Simple cell, Daniel cell, capital. Daniel cell. And then for electrolytic cell, this one you will learn a lot. If you go A levels also a lot. This one a lot. But in SPM, we just focus on one thing only. Okay. And then for Voltaic cell, we have simple cell and Daniel cell, right? Okay. How to differentiate these two? This one, simple cell. Okay. Simple cell, very simple. You draw one beaker. You draw two. Oh my god, so big. Two electrodes. One solution. Dot. And then you draw whatever apparatus you want. Okay? You must connect. Okay, this one solution. Simple cell. Daniel cell. Okay, this the part where this one. You got two types you can draw. This one atau this one. Oh my god. Okay, this one. Sorry for bad drawing. Okay, this one. Tapi mesti ada porous pot. Porous pot also is the same as the salt bridge per function. Tapi here got two different. Okay, ada electrode. Tapi two different solution. Inside also got one different solution. And then outside also got different solution. The cell we got two different solution. We call as Daniel cell. The one yang simple cell is using only one. And then here ada salt bridge yang US baru learn. Okay, like this. Salt bridge. Okay, in exam please draw nicely, okay? Sorry, I'm drawing my iPad, so it's a bit hard to control. Okay? And then sorry, I'm not PSV student. Okay. Okay, asalkan functional boleh dapat markah. Okay, no problem. Okay? Don't forget inside here also mesti dot sebab solution. Takkan you letak solid kan inside. Okay? Okay, and then astaga. We give space for the electrode. Electrode. Okay, like this. And then you connect with whatever apparatus you want. Okay, this one is the Voltaic cell. Okay, this one is Daniel's cell. Chimney. Okay, this is the main difference you can see with your eyes. Because banyak kawan yang like, how to differentiate this and that, okay? And then I was like, oh, you just need to know this one. This one is very simple, man. You can see with your eyes, clearly see with your eyes. You got eyes, you can know already. Okay? So just remember, simple cell only one solution. One, not solution, we should call it as electrolyte. One electrolyte. Then your cell got two electrolyte. Zinc and copper lah, basically. Then your cell is referring to zinc and copper. Yeah. And then for electrolytic cell, very simple. Asalkan you saw battery. And then if you move on to cathode, there's a bit scary thing, but that one I will tell you later. We just try to look at the simple thing first, okay? Okay, this one big. And then you guys must know how to draw this, okay? Tapi draw cantik-cantik, okay? This one is battery. For physics student will know, right? Okay, this is the battery, which we call as power supply. Then ada solution. Let's say this one is carbon. Carbon electrode. Okay. This one is the main difference between this one, voltaic cell, and electrolytic cell. This one, no power supply. No power supply, okay? But this one, other power supply. Electrolytic cell. And then, tadi I got say, right? The but this one is where the students feel like, actually, they already know that, oh, okay, voltaic cell is this one, electrolytic cell is this one. Okay. Ni ada power supply, ni tidak power supply. But when they met this question, they want to pengsan already. This one, they kasih gabung these two. Before I tell you the part, you need to know this characteristic. We study a bit of characteristic first, okay? Every part come from a reason. Every part mesti come from basic. If your basic is lemah, your part also lemah. Definitely. Because part, they like to twist from the basic that students really like to forget. Yeah. So if you want to be good in Kebat, your basic must be good. Okay, so we undergo like characteristic first, okay? So for voltaic cell and electrolytic cell, the similarities. Okay, dua-dua, the electron. Okay, I will put it as voltaic cell, this one electrolytic cell, okay? Dua-dua electron, dia akan flow from anode. Okay, remember electron always flow from anode to cathode, but current always flow from cathode to anode. Okay, if you're physics student, I think you already know. Okay, for anode to cathode. Okay, and then always remember anode oxidation. You just remember this: anode oxidation, cathode reduction, cathode reduction, cathode reduction. Because both have different terminal for anode and cathode. Some positive anode, but some negative anode. So I felt like so confusing. So I just tell myself that okay, anode is oxidation, oxidation is donate electron. Lagi easy. Jadi anode oxidation, cathode reduction. I like to put like this kasi short. Sebab you don't want to write so full when you self-study, right? Macam consuming time only. Okay? So this one is the similarities, and the difference is the very, very, very important part. Differences. Okay. We try to look from the aspect, from the structure of cell. Yang you can clearly see from your eyes. Okay, the structure. First thing, structure. If you guys ada question, you just on your mic. Okay. For structure, this one for Voltaic cell, right? Okay, I put BC, this one EC. So Voltaic cell, we have two different methods. Mostly two different. If two same, cannot. This one is very important. Different metal. Okay, this one very important. Very important. If two same metals, that's not voltaic cell already. That's fall onto electrolytic cell. So this one is to determine with your eyes, okay? So two different metals, and then into an electrolyte. Okay, this is the main one. Now you can see. I only take the extract, okay? And then for electrolytic cell, usually two carbon lah. Usually inert. Usually two different or same also can. Different or same also can. For inert or reactive or active lah, active electrode. Okay, two different macam copper, carbon, platinum. That one is different. Same is like two carbon, two platinum, two copper. Yeah, like that. Okay, for inert, right? For inert, okay, I write here small. Inert is platinum and carbon. For active, metal, usually metal. Okay, silver also consider active. Okay, inside here. Asalkan you don't see platinum, carbon, okay, that's definitely active. Okay, so here is very easy one. The first one. This one is the really the basic thing that you can see from your eyes. Okay, this one is structure. And we move on to energy change. This is the part that very important when you want to score in CAPA. Energy change. Energy change. Okay, this one for Voltaic cell, chemical energy. Chemical energy maksud, okay, undergo chemical reaction. Lepas tu dia akan produce energy. Everything in this world, this universe, if you do something ada energy. Mesti. This one fall below a bit of physics lah. Conservation of energy. So mesti if ada reaction, mesti ada energy. You can be in the heat form. If sebabkan like hot pack also, it's kind of chemical reaction, then produce heat energy. So when chemical reaction occur mesti ada energy. Jadi chemical energy, I put as E, okay, the energy, dia akan tukar pergi electrical energy. Sebab why the energy change is important? Because in this world, nothing can occur without energy. Like, cannot tiba-tiba ada energy. Like 1, 2, 3, pew, like that energy, like that. Mesti something convert. Okay? Jadi, that's why energy change is very important. So, the mula-mula it was chemical energy. Sebab ada reaction kan. Lepas tu kan, dia akan produce electricity from the voltaic cell. Okay? Tapi, electrolytic cell, as I said before, ada power supply kan. So, mula-mula pun ada power supply already. Plus, dua-dua ni inert. I mean, some active lah. But memang ada power supply already kan. Takkanlah power supply, so electrical energy to electrical energy. Itu bukan change tu, it's just the same. So, apa lagi kan? So, electrical energy, dia akan convert to chemical energy. Maksud, you give power supply. You supply the power into here, which is battery, dry cell. You bagi electricity here. Lepas tu, the chemical reaction akan occur here. As I said before, if ada chemical reaction, mesti ada energy. That's why we call it as chemical energy. Okay? Okay, mula-mula the first step dia bagi current macam ni. So dia pass through. Ada reaction sini. That one, the detail punya I will touch later. Okay? But this one, the voltaic cell, there's no power supply. Inside here, dia akan react with themselves. Like ni. Dia akan dissolve kah, dia akan jadi fat sikit lah. Jadi macam undergo reduction. Lepas tu, okay, the observation nanti I touch. Macam ni, atau jadi thin, macam ni. Okay? So this one is energy change. So this one bear in your mind. Okay, this one I will ask masa kebat. Macam ni je lah, okay? And then next one. Okay, this one where the most student confused until SPM. Cathode and anode. This one, actually for me, if I know this, if you understand why is it like that, I think it's very easy. You don't need to be confused. For cathode and anode, for voltaic cell, always remember, you remember this dulu, anode is oxidation. So anode is negative terminal. Okay? Okay, this one I will explain a bit easier. Okay, for zinc, no, magnesium is more active. Magnesium kan, magnesium is like you want to release kan. This one akan jadi cation kan. If cation, dia mesti release kan. If release, okay, I better use another example. Okay, we write dulu. I takut you guys confused. Jadi anode, we write dulu. Negative terminal, cathode, positive. Why actually anode is negative? Why oxidation actually negative? Because, okay, we can say tadi we got learn electrons, oxidation. What's the relationship? Oxidation and electron pair relationship ni actually, when release electron, we can say that one is oxidation. Why? Because let's say lah, let's say ada you ada bag, you ada satu bag full with electron. Macam you ada 1,000 ka, 1 million, 1 billion electron. Tapi you mau angkat kan? Mau angkat lah. Memang this one in real life the electron will not cover the space, but like just for example, okay? Terlalu banyak, like you want to bagi. Tidak muat already, like you want to angkat pun tidak dapat. And then the bag want to burst already, like plastic bag want to koyak already kan. Terlalu berat ke apa kah. Jadi kan, you mau donate. Tapi you try to tengok the charge. The electron charge, if you know, memang electron is negative kan. Memang electron tu negatif. You tahu kan? So, if banyak electron, maksud banyak negatif kan? Banyak negatif. Tapi I want to angkat this bag. Tapi mau koyak lagi. Then this stickman, dia think like, oh, I should donate. I should release some supaya I can carry easily. Supaya I can bring this to home. Jadi dia akan donate electron. Tapi donate electron kan. Tapi electron punya charge is negative. That's why anode is release electron and negative terminal. For Voltaic cell only. For electrolytic cell is terbalik. But we try to learn Voltaic cell first, okay? So this is the reason why oxidation release electron and is negative terminal for Voltaic cell. So this one, yeah. Cathode dia kurang elektron. Dia ni terbalik. Okay, ni cathode punya stickman. Dia want to fill in dia punya bag with electron. Tapi dia, misalnya, satu pun tidak. Jadi dia minta sini. If tidak negatif, apa lagi? Negatif, positif only kan in this world. Jadi, tidak negatif, memanglah positif. Kan? Jadi, positif lah. Dia memang positif. Before dia kena accept. Before they accept the electron from this anode guy. Jadi, tidak, satu pun tidak negatif kan. Jadi memang dia positif lah. That's why this one is positive terminal. That's why they want to accept the electron. That's why cathode undergo reduction, accept electron. Okay? Okay, so this is the detail, the reason behind. So for, okay, electrolytic cell is terbalik. Anode, okay, I will explain why. Don't worry, jangan takut. If you know the reason behind, actually, you don't need to memorize like anode negative, like that. For me, I think it's ineffective. Anode is positive. Mesti you try to make up story kah apakah, asalkan you dapat faham, no need to torture yourself hafal-hafal. That's how I study chemistry, that's how I got A+. Okay, macam ni kan. Okay, for this one mesti ada power supply. Okay, we draw balik. No need lah. We drag balik di sini. Okay, we draw here aja. If you know how to read the dry cell, the long stick one is positive. The short stick is negative, right? Okay, let's say here ada sodium chloride salt solution. Let's say you try this at home. Just solution. Sodium chloride solution. Okay, solution mesti ada apa? Water mesti ada apa? Hydrogen ion, hydroxide ion. Sodium chloride make up from what? This one is ionic compound, so they can break to sodium ion, chloride ion kan. Okay, so this is all the ion present in the sodium chloride solution. Okay, this one. Okay, tapi different charge kan. Okay, let's say positive tu perempuan, negative tu lelaki, lepas tu lelaki kena attracted to perempuan kan. Sini we don't talk about LGBT dulu, we talk about nature dulu, okay? So for positive, which is perempuan, the lelaki akan pergi sini. Hydroxide, chloride, okay? Lepas tu for lelaki, perempuan pergi akan sana, okay? Sodium, hydrogen, okay? Okay, I erase it here dulu, okay? Oh my god. Okay, macam ni kan. As I said before, the first step, ada kan plug kan, lepas tu you turn on the power supply, then the current masuk sini kan. Okay, so the current masuk already. And then this one, kena attracted here. Okay, the hydroxide here, chloride here, this one here. Memang kena attracted. Memang kena attracted. But there's only one ion will discharge. That one I will touch really detail later, but this one I will cover briefly right now, okay? So for here, let's say this one is very concentrated one. Let's say this is like 2.0 mole per dm cube. Okay, for if concentrated halide solution, memang the halide ion will selectively discharge kan. So halide is chloride ion. So chloride ion akan selectively discharged at anode, and for cathode is always pasal the E value, the standard electrode potential. That one I call as E value. So supaya simple kan. So E value, which one is MPR, more positive reduction, more positive. This one is negative something 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 voltage, and then this one is 0.00 voltage kan. So more positive is hydrogen kan. So hydrogen will be selectively discharged. So if you know here, okay, apa kaitan this with reduction oxidation? So for chloride, for anode, this is the reason why I always say don't memorize the sign with anode and cathode. Memorize that anode is oxidation, cathode is reduction. Okay, this is the reason why. Okay, before that, you need to know this MPO, LPO, MPR. Less positive oxidation, more positive reduction. Apa maksud ni? Ni kan actually refer to the standard electrode potential, which is E value. But anode here, okay, if I say concentrated halide solution, mesti the halide ion selectively discharge kan. Okay, so chloride ni akan undergo oxidation. Positif ni anode kan. Okay, sebab kan the ion kan mesti undergo oxidation, takkanlah this one undergo reduction kan. Kan sini positif ni anode. Jadi this one dia akan undergo oxidation. So you can see like the greenish gas bubble produced here. You akan see too. Okay? And then this one is E value, MPR, more positive reduction. So hydrogen gas is colorless, right? So you can see colorless bubble gas here. Colorless, okay? This one is actually colorless, okay? This one colorless. This one is not like this, like maybe bubble. Okay? So this one, dia akan produce kan. Tapi this one need to accept dulu kan, electron. Okay, macam ni. In order to produce gas for chloride, mesti ni undergo oxidation, and then this one undergo reduction kan. So we can see that for anode is positive. This one is actually very easy for electrolytic cell. Most of the question they will give you from anode. Tapi some they like to give you from cathode lah. But as far as I see, they really like to give like this. And then you put positive, negative, and then you see like this kind of thing. And then if they give the bubble, and then all the observation, and then which one cathode and anode, then you know already kan. Anode is positive for electrolytic cell, and then cathode is negative for electrolytic cell. This is the reason why. Because the ion kena attracted is different ma. If here negative, sini go there, and then this one go there kan. And then they say like greenish gas bubble is produced at here anode. Then we must know that this one must be attracted to here. Tapi this one is negative. What is the terbalik of negative? Positive kan? So positive here. And then if this one, if mesti undergo oxidation in order to produce this kan. Jadi, it's obvious that anode is positive for electrolytic cell. This memang, if you don't know, atau like you memang sesat the electrolytic cell part, memang a bit susah want to understand the reason behind of it. Tapi, if you already know that Voltaic cell anode is negative, cathode is positive, then for electrolytic cell, you just kasih terbalik only. There's no big deal. Sebab dua-dua ni memang different. So memang you hafal one only, then the other one terbalik also actually good technique to memorize if you want to memorize. Okay? But if you yakin, I want to know the reason behind of it. I don't want to hafal only. I want to understand. Then you can use this method. Okay? So for this is the end of the cathode and anode. And then flow of electron. It's the same just now. Here, okay? Flow of electron is just that they kasih kite with the anode positive and then anode negative. That one they want to kasih twist only. Actually, this one got in textbook, but I don't want to use this sebab you memang know anode is positive, cathode is positive, anode is negative, cathode is positive for voltaic cell. And then if you know the electron flow is anode to cathode, there's no big deal. And then they don't really like to ask this kind of question. Just bear in your mind that electron flow from anode to cathode, no matter what voltaic cell or cathode or the electrolytic cell, memang electron flow from anode to cathode. The current is terbalik, cathode to anode. And then the negative terminal and then the positive terminal also the same thing. If you know this thing, memang you can differentiate already. If you know this three, memang you can get full mark for this part already. Okay, why this one is important? Actually, this all three is important for but for kebat. If you know this two, I can guarantee you can get full mark. If you know the techniques also lah. Okay, let's try to see the one yang kebat that I want to show you guys just now. Okay. Maybe if you guys ever tried the trial 22 or 23, they like to gabung it. They like to gabung. Like, actually horizontal, but I make it easier to see. Okay, I draw on top, okay? Ada macam ni. Ada salt bridge. Salt bridge. In exam, you draw nicely, okay? Ada ni, ada ni. Dot, 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 dot. Okay, macam ni kan? And then this one, let's say zinc. Zinc, and then, let's say copper. The zinc is negative terminal kan sebab dia banyak elektron. Lepas tu dia akan undergo oxidation. Tapi in the kepat, dia kasi gabung macam ni. Macam ni. Lepas tu ada electrode gabung macam ni. Then one electrolyte like this. Okay, this is the kepat that they really like to bagi. 22 also got in the trial. 23 also got in trial. Okay, so this one how to solve? Which one is electrolytic? Which one is voltaic cell? You need to identify that one first. So we try to look on top first, okay? We try to cut here, we don't see here first. Okay, is there any power supply here? Like you don't see the wire first. Then the power supply kan? Jadi we can say this is voltaic cell kan? So the salt bridge is so obvious kan? So this one we call as voltaic cell. Okay. Second step, identify which one is negative, which one is positive. We already know that zinc is much more electropositive kan? So memang dia akan undergo oxidation kan? If banyak oxidation, if undergo oxidation for voltaic cell, banyak electron kan? You need to know how to kasih kaitkan, how to remember, okay? This one also one part of skill. So first thing you ingat, zinc is electropositive. So dia memang aktif. So dia akan undergo oxidation. Tapi oxidation for anode, for voltaic cell, if banyak elektron baru undergo oxidation kan sebab mau bagi elektron kan. So if banyak elektron is negative. So we can say that zinc is negative, right? So you put negative here. Alamak. Okay, then you put negative here. Supaya you tidak heran which one is positive. Okay, and then takkanlah dua-dua negative. If you already identify one is negative, one must be positive kan. Tapi just to make sure you don't trust yourself. You kan ada trust issue. Sampai exam pun mau tekan 1 plus 1 equal to 2 kan. Jadi, you can say copper ni kan kurang elektron. dia suka accept kan. Jadi kurang elektron is negatif. Kurang negatif memanglah positif kan. Jadi it's positive. Okay? And then okay, after you identify, this is one part of skill that I used during my SPM. During my beginning of my Form 5 when I got like confused. Okay, what I do is sebab the diagram in kena printed kan. So I use the pencil. I use the pencil to shade here so that I can see this whole thing as the power supply. You know the box, like the power supply box, that one. I will see that as this. So the negative I drag to here, positive I drag to here. And then if you really used to the battery sign, then you can draw like this. There's no harm. Asalkan your answer is correct, you draw on the diagram, they don't care. Okay? So this one is one of my skill. I can see draw one line here, then I put negative, positive. And then this is the part where you need to remember. If kena bagikan this one from the external kan, this one is not the sendiri punya here, but this one is sendiri punya kan. Sebab ada salt bridge, ada ni, ada transfer sini sana. Tapi this one memang dua-dua inert, dua-dua carbon. Tapi ada power supply. Kan ni the current from the outside masuk inside. Kan this one is inside to outside kan. Jadi this one we can say is electrolytic cell. For electrolytic cell, I'll tell you is terbalik kan. Anode is positive kan. So you tulis dulu anode. If you already tulis anode, you memang know it's oxidation kan. You put personal notes here first. I also do like this sebab supaya you won't confuse yourself. So tulis je. Negative is cathode. Cathode is what? Always reduction. No matter what, no matter sign the change in the universe, memang anode is oxidation. Positive, negative, anode memang is oxidation. So better to have like this. Okay, all the information got already. And then you can solve already. If they give you like solution, then you write down all the solution, you write dulu ni. And then lepas tu, let's say like copper sulfate to sulfate. Then you kasih break to copper to sulfate. Itu je. Lepas tu, which one kena attracted? This one positive ions kan. Here negative ions kena attracted. Lepas tu you jawab. That's all for Kebat. And then I will touch a bit detail for the electrolytic cell right now. Okay, before I move on to very detailed electrolytic cell, is there any question? Okay, Kak. All good. Okay. So you're everyone pandai yo. Okay. Good. Heart. Okay, which part is heart? Memang chemistry ni memang not considered not that easy lah. If you understand baru you feel like a bit easy lah. Boleh lah. Kan? Okay. You can ask question if you rasa hard. Confused. Oh. Daniel cell must have salt bridge. Salt bridge is not compulsory for all the simple cell. Salt bridge, the function, you think about the function is to allow the movement of freely moving ions. Right? It's not necessary to use salt bridge. You can use porous pot. That one also have the same function as the salt bridge. Salt bridge, tidak semestinya use the glass thingy. You can actually use the filter paper. You can see crumple it, and then you can soak into the sulfuric acid. You can use it as salt bridge. Salt bridge and Daniel phosphorus pot is basically the same thing. Only the drawing is different. My brain's still at the oxidation part there. Oxidation part for which one? Chapter 1 have an essay or not? Yes, chapter 1 essay is very popular. Already clear SPM 2023, section B, and I chose that. It was very easy. Our essay was very easy. Yeah, chapter 1 by essay for me, if you know the format, ayo, 20 mark in your hand already, full mark in your hand already. Memang easy lah, chapter 1 compared to chapter 2, chapter 3. Memang chapter 1 is very easy. Because you do it in the cute table, I confirm 20 mark in your hand already. The oxidation agent, oxidizing agent and reducing agent. Oh, you don't need to confuse. This one memang you just hafal je. Oh, oxidation is reducing agent. Reduction, oxidizing agent. That's terbalik only. Okay? Okay, and then for electrolytic cell, this part yang I really like it. And then I used to confuse a lot, but now no more. Memang easy already lah. Okay, so electrolytic cell, dia special sikit. Dia ada banyak benda ni. Lepas tu ada banyak teknik, ada benda mau hafal, okay? Okay, we discuss right now. And then, this one ada 3 type, okay, electrolytic cell. We kasi separate the 3 first. Because this one, I separate according to the factors, okay? Ni ada factor ni. And then we will try to look banyak cases. Like the possible question they can ask. Okay? This one, we draw dulu. So first factor, what we want to see. Concentration. Let's look at concentration. Concentration, the factor, as you can see, ada in the textbook also kan. Tapi the concentration is referring to the electrolyte punya. Kan ada ni. Electrolyte is the solution, okay, yang kena dip. Ini ada battery, macam ni kan. Dot. This one is called as electrolyte concentration. Okay, so for SPM 2023, 1.0 was concentrated. This one actually got a lot of arguments in one Malaysia ni. 0.00001 is diluted. This one is very important. Dilute, you need to know the concept of dilute and concentrated. You need to know how to differentiate. Dilute is the one yang you brought a mango juice. Lepas tu, the ice melt. Lepas tu, your mom tiba-tiba tambah some water sebab dia bilang, oh, too sweet. Tapi, when you drink it, the taste macam, the mango punya taste hilang already kan. So, that's what we call dilute. Banyak water kena add on. That one we call dilute. Concentrated is like, you baru je blended mango. You didn't put any ice or you didn't put any water. That one is very, very concentrated mango juice. That one is concentrated. So, for molarity, if you know, like the concentration, dilute is 0.0001, 0.001, 0.1, 1.0 for SPM was concentrated, so I will put it here. 2.0 until the maximum is 12.0. Okay? So like 0.0000001 also can. Dilute concentrated. This one must know how to differentiate, or else you cannot solve. Okay? Okay, so for concentration, what solution should we use? Copper sulfate. Oh, no. For concentration, we should use sodium chloride. We want to use yang ada highlight. Okay? Solution. Tadi sudah kan, solution kan ada hydrogen ion, hydroxide ion, sodium ion, chloride ion. And then positive, negative kena attracted. This one. Okay, the same thing, okay, like this now. And then concentration. Let's say the concentration is 2.0. 2.0 mole per dm cube. Okay, now we know that the solution is very concentrated kan. Okay, so the first factor is concentration. So what do you mean by first factor is concentration? The factor that we're looking on today, which are the 3, all refers to and not only. For cathode, all time in the universe, in the all time, we use the E value. E value is the standard electrode potential. The one yang you go textbook page 24 ada yang ada list tu kan. The one we call as standard electrode potential, shortly E value. So that one is always for cathode. For anode ada 3 different thing. Anode ni macam banyak benda lah, mau hafal. Tapi cathode ni very senang. Only this one, cathode. So remember, okay? No matter what, there's no factor for cathode. Memang ni E value only. Okay? So for concentration, we mostly focus on anode, okay? So for anode, as we know, undergo oxidation kan. So oxidation, but how to determine? Ada dua kan. Tapi mesti ingat, only one ion will be winner. Only one yang akan selectively discharge. Now, there's some reason why we call it selectively discharge. Only one yang jadi can winner. Top one yang ni one. Jadi which one? Ni kan ni. Dia bilang concentrated, which is 2.0. If the question bagus, they will tell you concentrated solution which. But if the question jahat, they won't tell you. Okay? So must know lah this one. So 2.0 is under concentrated. Concentrated maksud the sodium chloride ratio is greater than the water. Okay, the concentrated sodium chloride is greater than the water. Maksud the hydroxide ion came from where? Came from water kan? Okay, now we can see who's the winner. Okay, this one under here kan? Under here, and then this one under here kan? Which one is greater actually? Sodium chloride is greater than water kan? Sebab concentrated. Jadi which one is winner? Chloride ion is the winner kan? Sebab dia lagi strong. Jadi chloride ion will undergo oxidation. So we write the half equation dulu. So oxidation, you write dulu. You should rasa like confusing. You write dulu. Chloride ion, dia akan undergo oxidation. Ni kan? So if they ask the observation, what's the observation? You can say, okay, let's see greenish yellow. You can say greenish yellow bubbles are produced at anode if they ask the observation. Okay, this is the reason why. This one oxidation, okay, we found already one. Okay, the reduction. Reduction part is always cathode, right? Cathode is always pasal E value. E value is the one yang, okay, I tried to show you. Chemistry. Oh, not form 4, it's form 5. Okay, if you go here, yeah, this one is because E value. If you see, okay, hydrogen and tadi apa? Hydrogen and sodium. Okay, sodium ni sini. Negative 2.71. And then hydrogen is 0. Kan? 0 kan? And then reduction, always remember MPR. MPR stands for what? More positive reduction. More positive reduction. Hafal je MPR. More positive reduction. More positive. Okay, which one is more positive? 0.0 atau negative 2.71? Mesti 0.00 is more positive kan? So, the winner is hydrogen. For cathode, the winner. Okay, we use different color lagi. The winner. Jadi, hydrogen is selectively discharged. So, reduction. Ni hydrogen. Lepas tu, hydrogen dia akan accept electron sebab reduction dia akan bagi ion. Okay? That's it. Senang kan? Yep, this one is ion, not gas, sorry. Ion. So, okay, produce this one. Okay, so we can say, okay, colorless bubble gas, okay, colorless. Hydrogen gas is colorless, okay. If they ask for observation, you say colorless gas bubbles are produced. If they ask the substance, hydrogen gas, okay. They ask for substance for this one, is you just say chlorine gas, okay. And then this one is the detailed explanation, and then the technique of answering, like how to answer, how to write essay. I got shared previously. Where already? Oh, here. I got shared already in the group. This one is the essay part. You need to do like this. The essay, you construct table like this. First, you write inside here. That's how you write essay. Chemistry essay is not like language, as you know, not like karangan, not like English. Today you need to write in the table. So this one I already share in the group, so you guys can have a look. Okay. Today's class is more like I explain what's the reason behind or how to apply. This one is more on technique part, so you guys can have a look. Now you know already kan, oh why is it like that? Why is it like that? It's better to dengar the explanation rather than okay, copper electrode because the brown solid deposited around the electrode. It's something like ineffective study method. Reading is not effective. Mesti know the reason behind. Okay? So far okay for the concentration. No need for paragraph. For paragraph, I never read essay in paragraph. I always did in the table form because it's very easy to see, easy for the pemeriksa to mark, and easy for me to check balik also. So for concentration part, okay, right? Yeah, should be easy for concentration. Okay, let's move on to, okay, next one we want to see is the active. Yeah, this one I like it. This one actually got my case. They like to give in K-part. Okay, so this one active. Active metal maksud the electrode besides platinum and carbon. Can be zinc, can be copper, can be silver, not gold lah, okay? Can be magnesium, can be aluminium, and all the metal thingy. Okay, let's say paling common one is copper. Yeah, very common. Let's say this one is carbon, this is copper. And then ada okay. This one actually can be dua-dua copper. Dua-dua can be active. But as I said before, memang cathode is memang E value lah kan. Memang E value je. Okay. So today we'll focus on anode kan. Sebab anode is the paling banyak factors. Jadi we draw electrolyte dulu. We put copper sulfate, okay? No. We put different from copper. Iron 2 sulfate. Iron 2 sulfate, should I? Yeah, iron 2 sulfate. Solution. Okay, we know already kan. Solution is this one, and then Fe2 plus sulfate ion. Okay, this one positive, negative. So attracted to sulfate ion. Apa lagi? Hydroxide ion. This one ada surprise sikit. Not that surprise lah, actually. Okay. Why do we learn this actually? Active anode. We call it active anode. Why is this important? Okay. If you see something, the electrode besides carbon or platinum at the anode. Okay, you tulis dulu. We know already the long stick is the positive. Positive is anode for electrolytic cell. Kan? Ditulis dulu terang-terang. Anode. Okay. Anode. Tapi, it's not carbon. It's not platinum. Maksud, it's active anode kan? Okay. Bear in your mind, active anode always, no matter what the solution, no matter what the E value or whatever, anode, active anode, dia sendiri undergo oxidation. This is the very, very, very important thing. Sendiri undergo oxidation. Neglect this all the ion. That's why in the textbook also got, there is no N ion discharge. Because this is negative ion, which is N ion kan. So there's no N ion discharge. Sebab copper kan cation kan, copper 2 plus kan. Dia sendiri dia akan undergo oxidation. Okay? So coppernya undergo oxidation. Okay, we tulis dulu. Sebab copper ni kan dia sendiri react bak. Dia bukan inert macam carbon and platinum. Jadi oxidation ni copper. Okay, we try to write copper punya oxidation ni. Copper 2 plus 2E. Okay, this is the half equation for copper. Okay, so if they ask for observation, what you need to write? Copper electrode. Okay, this one. Mula-mula kan macam ni. Tapi dia akan change pergi ni. Like this. Dia akan jadi thinner. Thinner lepas tu melt. Ya, macam ni. Nampak macam bida kan? Ya, memang bida. Okay. So this one akan jadi thinner. Thinner macam ni. Okay. Here also I got right. Okay, copper electrode becomes thinner. Okay, this is the reason. This is some sort of technique, okay? This one, all I got from my teachers. My teacher who was SPM marker, chemistry SPM marker was for 10 years plus. So memang I learned under her, and all my answers are based on standardized SPM marking scheme. So you guys can trust, okay? So the reason, okay, how to write? You cannot simply write, okay, don't, for chemistry, if you want to get A plus, you cannot just like, the content inside there the sentence, whatever I write, asalkan ada content tu inside, tidak payah like strictly follow kan like that. No, pemeriksa tidak suka tu, tidak akan bagi markup. It's very strict. So if you want to get A plus, mesti kasih susun cantik-cantik, state the facts only, root cause. Macam copper as active anode undergoes oxidation to form copper 2 ions. What I mean is, just don't write the nonsense. Just go straight to the point. Examiner will love you. Terus dapat A plus. Essay is the part that you can impress the examiner. Essay is very important. Okay, you buka the paper, if were you, okay, nampak macam table macam ni, and then pengenlah cantik, like very straightforward, okay, A plus in your hand already. Yang the small notes tu ni kan, is actually your own notes. They don't cut mark or they don't tambah mark lah. If like small notes like this, so you can just write just for your own. Okay, so if the observation they ask, copper electrode becomes thinner, the reason copper is active and not undergoes oxidation to form copper 2 ion. This notes don't worry, okay? I already shared previously. Okay, so for cathode, always is the same as E value, same as this one. E value. Okay, how to answer? No problem. Look at this. This one. Cathode is always this one. As you can see, there are 3 types of factor. But you can see if you realize, for cathode, you always can see the word E value. This clearly shows that for cathode, the factor is always E value. Okay, no matter what. So you saw like copper, like zinc, it's memang E value. So don't worry. Cathode is very easy. Okay, so now we move on to the last one. Which is dua-dua E value. Sebab anode pun ada E-value per factor, okay? Bukan cathode je ada. Okay, E-value. Okay, we draw macam ni. Okay, macam ni. This one, dua-dua carbon lah. What solution? Copper to sulfate lah. Solution. Okay, we know solution is hydrogen ion, hydroxide ion, copper 2 ion, sulfate ion kan. Okay. Long one. Positive, short, negative. Jadi, negative pergi positif kan kena attracted. Okay, we go here. Still sulfate ion. And then here, okay, the leftover. Okay, macam ni. Okay, E-value. Okay, this is what I was waiting for, E-value for anode. Okay, actually in textbook, adakah sulfate ion? They got give. Okay, let's try to compare. Positive 2.01 and tadi apa? Hydrogen kan? Oh, hydroxide. This one and hydroxide sini kan. Okay. And not LPO kan. Less positive oxidation for E-value. Less positive. Okay, which one? Okay, let's try to compare. Okay, another competition. This one is less positive and okay. Macam ni. VS positive 2.2. This one is hydroxide. This one is sulfate. Okay. Anode this one okay. Anode punya competition. Anode is LPO. Less positive oxidation. Okay, let's see who's the winner. Less positive. Which one is less positive? It's very obvious. 0.4 is less positive than 2.01 kan. If you cannot think like, which one is less positive? You just try to see which one is more close to 0. More close to, if less positive kan. Less positive, you start to see which one is more close to 0. Okay? So, the smaller the value is less positive kan. Sebab dua-dua ni kan positif. And then, let's say like you want to see the magnitude only pun ini yang less kan. Jadi, hydroxide is the winner for anode. So, hydroxide ni dia akan selectively discharge. Okay, this is the winner. Yay. And then for cathode. Cathode is apa? MPR. Okay, let's see who the winner. Okay, let's see. Copper sama hydrogen. Okay, we use different color of highlight. Copper, where are you, copper? Okay, copper here. Di atas jangan. And then ni. Alah, very senang want to see kan. MPR, more positive reduction. Which one is more positive? Alah, so obvious. We can see copper is the winner kan. This is memang more positive than 0.00 kan. So, copper won. So, copper undergo reduction. Macam gitu. Actually, chemistry ni very fun to learn. If you know already the reason behind, how to apply, okay. Jangan stress, okay. So, copper, dia akan undergo reduction. So, okay, how to write, what's the technique? How to get mark? Takkanlah you just like, copper to undergo reduction. Titik. Can get full mark kah? Kalau terdapat tu, terdapat. Mesti ada teknik. Chemistry ni full of teknik je. Okay. This one for anode, tadi our one was hydroxide and sulfate kan. Tadi the winner, okay, here I got use the same solution. The winner is hydroxide ion kan. So how to write? If they ask for observation, you can write colorless gas bubbles are produced. Why colorless gas though? Oxygen is colorless kan. You try to breathe in oxygen, memang colorless kan. Okay. What's the reason? Nah, this is the E-value punya factor. So you need to use back the E-value for your reason. This is where you can get the mark, like you can impress the whole thing, like the impress the pemeriksa. Okay, so you start with the you don't need to put the for chemistry they don't really look into English. You straightforward the E-value of hydroxide ion is less positive than sulfate ion. You use back the one less positive. E-value less positive. Okay, that one is very chantik already, the wording. Very straightforward. Like everything is there already for to get mark. Okay. So E-value of hydroxide ion is less positive than sulfate ion. As simple as that. For cathode also the same thing. We use back the E-value. But then if they ask for observation, we say brown solid is deposited around the electrode. What is brown solid actually? Copper. Copper, if you try to Google, like try to Google copper in room temperature, you can see the brown solid. Yeah. So the observation, brown solid, lepas tu the reason, use back the E-value. E-value of copper 2 ion is more positive. I got right here. If you guys tidak nampak this kind of notes in my channel, I will try to resend. But if you scroll up, memang ada tu. I got share previously during my batch SPM. Okay, so this one LPO MPR. This one is only apply for E-value. Okay, that's why I write under the E-value. Okay, so this one is actually very useful for me. LPO MPR. Okay, jump LPO is like, I don't know how, I'm not really good in like acronym, but this one is like mama potong rambut macam gitu pun boleh. LPO, you guys try to make like if cannot hafal. So this one is actually very useful. And then this table actually for me, I use this to study for my SPM, and I can guarantee I can get full mark for my bagian BSA. Nang keluar like this kind of thing. Our one keluar like apa? I remember it was type of electrode. It was very easy. So if you use this, memang useful lah. This one whole page. Okay, ada observation, ada reason lagi. Sini pun ada reason, sini pun ada further explanation. Okay, so far, now we already cover electrolytic cell. For electrolytic cell, actually got a lot of application. Macam electroplating, like the spoon, like the impure, pure metal, that one is not focused for today. That one I will try to make the note as simple as I can, that I try to share. Okay, because this one is the main one they really like to ask in essay and carries big mark. So until here, okay, any question, feel free to ask. Okay, jangan malu-malu. Everything good wow, everyone can understand 100%. For me, I study like I faham 99% also. If 1% tidak cukup, mesti tanya cikgu. It's okay, ada yang memang first time kan memang ada confusing part. Why everyone so far so good Wah, hebat oh. When I learned this first time kan, wah, I felt like so overwhelmed. Very understand. Wow, okay. Wish you guys very hebat. I salute. It look like my brain is not function already. Oh, it's okay. Memang berat sikit. Memang berat. I will share all the notes. I will share. You try to read carefully. Like you try to digest sikit-sikit, step by step. No need to digest everything at one go. Memang berat lah memang. We faham, okay? Thank you for your info. I can face to SP. Belum lagi, just one topic. Belum lagi face SPM 24. Oh, you're Chinese. Sorry, I can't speak Chinese. But you need to get used to English because memang SPM memang need to learn English kan. You try to push yourself a bit only. Okay. I can believe in you. Memang you can too. You guys, everyone, so hebat. My first class cannot faham already, oh. Okay, any question further? And then the observation, the color, that one, I will make the notes cantik-cantik. I color sikit because it consumes a bit of time. So later I will share in the group. So today we end here. Okay, before we end, other question? Like for real tiada. Why everyone so hebat? Okay, for real tiada, okay? Okay, then, okay. Then can we end today? If you've got question, you can ask in the channel. Okay? Okay, thank you guys for joining for today. If you terapat faham, you can try to digest lah. Just read balik-balik and then, yeah. Okay? Have a good rest.